Welcome back. In our last lesson, we learned about the theoretical concepts of eigenvectors and eigenvalues. Today, we're going to see them in action in one of the most widely used techniques in all of data science, principal component analysis, or PCA. First, let's understand the problem PCA solves. In the real world, our datasets can have hundreds or even thousands of features. This is called the curse of dimensionality. With so many features, it's impossible to visualize our data, our models take a very long time to train, and they are more likely to learn noise instead of the real signal. The goal of PCA is to fight this curse. It's a dimensionality reduction technique. It takes your high-dimensional data and projects it onto a new, much smaller set of dimensions, called principal components. The magic of PCA is that it does this in a very smart way, ensuring that it preserves as much of the original information, or variance, as possible. So how does it work? This is where our knowledge of eigenvectors pays off. PCA starts by looking at your cloud of data points and finding the direction through it that has the absolute largest spread, or variance. This direction is the first, and most important, principal component. It is the eigenvector with the largest eigenvalue. Then, it finds the next most important direction that is perpendicular to the first. And so on. Finally, it takes your original data and projects it onto these new, more informative axes. The result is a brand new dataset with fewer, but smarter, features. You might go from 50 original features down to just 2 principal components. These new features are ranked by importance, and each one is a carefully calculated combination of the original features. This makes your data much more compact and efficient to work with. We use PCA all the time in machine learning. Its most common use is for data visualization. By reducing a complex dataset down to just 2 principal components, we can easily create a 2D scatter plot and visually see the structure and clusters in our data. It also dramatically speeds up model training and can even improve performance by filtering out noise. So, principal component analysis is the mathematical art of intelligent data compression. It uses the power of eigenvectors to find the hidden structure in your data and summarize it in a much more efficient way. In our next lesson, we will shift our focus to the building blocks of neural networks themselves, and look at the math of a single neuron.